fireworks displays are dramatic, colorful, and mathematical. Although you may not be able to see the path of the fireworks in the night sky, the real pyrotechnics happens at the algebraic level. The path of fireworks is a parabola, and a parabola is the graph of a quadratic function. A quadratic function in standard form is written as y equals ax squared plus bx plus c, and the shape of the graph is a parabola. A, b, and c represent different numbers, and each has a different effect on the graph of the function. The constant a affects the width of the parabola and its orientation. The constant c is the y-intercept, where the parabola intersects the y-axis. And the constant b affects the horizontal location of the parabola. So now we have a blueprint for creating the path of fireworks. So let's create a fireworks display. Let's restrict our graphs of the parabolas to the first quadrant. In fact, if we let c equal 0, so that the y-intercept is at the origin, then the graphs will be a model of fireworks launched from the origin. Graphs of this sort have this kind of equation: y equals ax squared plus bx. This equation is easily factored into vertex form. The advantage of this form is that the roots of the factors show where the zeros of the function are located. This corresponds to where the fireworks are launched and where they would land if they didn't explode. But how can you control how high the fireworks go? We know that fireworks launched from the origin will land at x equals negative b over a. Midway between these 2 points is the vertex, or highest point on the parabola. The x-coordinate of the vertex is therefore x equals negative b over 2a. And the maximum height of the fireworks is the y-coordinate at x equals negative b over 2a. We now have all the tools we need to plan our fireworks display. So, suppose that you want to launch 3 volleys of fireworks. The first volley explodes at point 20,75. The second volley explodes at 20,100. And the third volley explodes at 20,125. The 3 points have the same x-coordinate, and so they are on the same vertical line. What are the equations of the 3 parabolas that describe the paths of the 3 volleys? Let's use the TI Inspire to find out. Turn on the TI Inspire. Create a new document. You may need to save a previous document. Create a graph window. Change the window settings to show the first quadrant. Press Menu, and under View, select Window Settings. Change Xmin to 0, Xmax to 50, Ymin to -10, and Ymax to 150. Hide the entry line by pressing Ctrl and G. Add points to the first quadrant by pressing Menu, and under Points and Lines, selecting Point. Move the pointer to the middle of the x-axis. From there, move up to place 3 points equally spaced and aligned vertically. Press Enter to create each point. Add coordinate labels to each point. Press Menu, and under Action, select Coordinates and Equations. Use the navpad to move the pointer above each of the points. Press Enter once to display the coordinates, and press Enter again to place the label on the screen. Repeat for the other 2 points. You'll see that the coordinates don't match the desired coordinates. Hover over the x-coordinate for one of the points and press Enter twice to edit the coordinates. Change the x-coordinate to 20. Press Enter. Changing the coordinates changes the location of the point. Repeat this process for the y-coordinate. Repeat with these coordinates: 20, 100, and 20, 125. The coordinates are now the correct ones. We now need to find the 3 quadratic functions. We know the generic form of the equation is y equals ax times the quantity x plus b over a, where b over a is the non-zero root of the function, which happens to be at x equals 40. We substitute the xy coordinates for the 3 points and solve 3 separate equations, in each case solving for a. We get 3 solutions. A equals -3 over 16, a equals -1/4, and a equals -5 over 16. Now input each function. Press the Tab key to go to the entry line for F1. Input the first function, -3/16 x times the quantity x minus 40. Press the down arrow and input the second function, -1/4 x times the quantity x minus 40. Press the down arrow again and input the third function, -5/16 x times the quantity x minus 40. Press Enter to see the 3 parabolas. Enjoy the fireworks!